problem. This is 1.119. So what the problem says, a locomotive have mass m. So there is a locomotive, something like train kind of thing. So locomotive has mass m. So I have a locomotive. I don't have a locomotive, of course. So Irodov has a locomotive of mass m. And start moving so that its velocity varies according to law. So this locomotive starts moving along some track, and the velocity of locomotive is given by, so v is given by a times, let us put x. In problem is given s. Let us replace this s with x because we are habituated with x, where a is a constant. A is a constant. So this we have to keep in mind, that a is a constant. Now s is the distance covered. So x is the distance covered. So x is what? Distance covered. So this is the distance covered. So x is the distance covered, it is given. Now find the total work performed by all the forces. So we have to find total work by all the forces. So this is the by all the forces. So now we have to find what is the total work done performed by all the forces. So this is enough that we have to use the change in kinetic energy equals to work done is theorem, because if you see, change in kinetic energy is equals to work done, and in this formula this is the total work done by all the external forces. So this formula is valid. This is by all external forces. So this is true for all external forces. So this gives me hint that I should to apply change in kinetic energy equals to work done. So this says find total work performed by all the forces which are acting on the locomotive during first t second after the beginning of the motion. So during first t second, so time is given. So time is given during first t second, and it is also given motion starts with zero velocity, that is starting with beginning of the motion. So this means initial velocity is zero. Initial velocity is zero. That is, let us say u is equals to 0. Now if I apply change in kinetic energy, initial velocity is 0. Now I have to see final velocity is v. So change in kinetic energy I can write, let us say final velocity is v. So final kinetic energy is half mv square minus initial kinetic energy is half mu square, that is 0 square. So simply change in kinetic energy is half mv square. So this means total work done performed, change in kinetic energy equals to work done. So if I apply, this becomes half mv square is equals to total work done. So this is the change in kinetic energy equals to work done. Now I have to simply find v. So what is the value of v? If I know the v after time t, I know the what will be the work done. So to find v after time t, because you see this velocity is given by a root x. V is given by a root x, but we don't know what is the x after time t. If I know what is the x after time t, then I can find what is the v at time t. So my target is to find x at time t. At t, what is the x at time t? So what we will do, now I can write velocity as dx by dt. Things are very simple. A root x. Now I can simply write dx by under root x a dt, and this time goes 0 from t. Initial velocity is initial displacement is x. Let us say final displacement is x. So from 0 to x. If I integrate, so this is x to the power minus half dx is equals to a t dt integration t 0 to t. Now x to the power minus half integration will be x to the power 1 by 2 divided by 1 by 2. Are you getting or not? X to the power half is same as x to the n plus 1. So n plus 1 is half divided by n plus 1. So this is half. So you will have this goes from 0 to x. So this goes from 0 to x. So this is a t. Now you see, so this is 1 by 2 root x simply. So this 2 goes up. So this is 2 root x is equals to a t. So now I know what is the x after time t. Basically I know root x after time t. Root x is at by 2. So velocity you see from here, velocity after time t is given by this equation. Velocity is a root x. So velocity is a root x, and root x I know, that is at by 2. So velocity will be at square by 2. Are you getting or not? So this is the velocity at square by 2. Now I have to put this velocity here, that is change in kinetic energy equals to work done equation, then I will find the total work done. So you see, total work done I can write here. So work done total will be nothing but half mv square, half m, and v square is a square t4 by 2 square. So a square t4 by 2 square, that is 4. So total work done will be 1 by 8 m a square t4. Okay, let us copy this one. If you are not getting, we will discuss. Copy this one. So you will have a square here, and this is a square. So you will have a4. So a square, it will become a4. So this is a4. We have to make the correction. This is a4. So 1 by 8 m a4 t4. So you see in this problem, what we see, fairly I have gone slightly fast in this problem because this is a fairly easy problem. You see what we have done. So we have applied change in kinetic energy equals to total work done. This is the important. We are asking the question, what is the total work done? What is the force work done that is performed by all the forces? That is the important point. If I know, if I have to find the total work done, this gives me an indication that I have to apply the kinetic energy theorem. So change in kinetic energy equals to total work done. Initial kinetic energy starts from beginning. This means initial kinetic energy is 0. Let us say after time t the velocity is v, and then we can find the velocity and subtract, and then we can find the corresponding equation. So this is very easy problem. We'll discuss the next problem.